Okay, we're going to look at histograms and also the shape of their distributions and what that could mean in terms of what measure of center we'd use to represent the actual center of the data. So if you take a look at the concept up here, we've got three types of distributions. We've got skewed left, meaning the tail or the thinner end is on the left. We've got symmetric, which means it looks pretty balanced. And then we've got skewed right here, with the tail on the right side, so that it's skinnier on the right side. Okay, so you can see what it means, right? Skewed left means most of the data is on the right side. Symmetric means it's pretty much a mirror image, almost like that pretty bell curve you normally think of as your normal curve. And then the skewed right means most of our data appears on the left, so it's more front heavy. Okay, we're going to be doing histograms using frequency tables to determine the shape of our distribution, and then we can look at what those shapes could actually mean in terms of measures of center. So for some reason we don't have an actual graph on these notes, so we're just going to sketch to the best of our ability, but I want you to remember for your histogram our bars should be evenly spaced apart, so please use graph paper on your assignments. Okay, so some key points to our histogram. We've got this is basically your X, this is basically your Y, the number of hours and frequency, so we want to make sure we label our axes here and what they represent. So this is number of hours, and this on the Y is the frequency. And then what you want to do is you also want to, let me write that a little better, you'll also want to name your histogram, so we want to put a title on this thing. So if you take a look at what the situation is talking about, we're looking at the number of hours spent on homework last week. So you might just title this time spent on homework. Right, but something to just tell me what the entire histogram is representing here. That's what we're looking for. Okay, so the frequency table is already done for you, so we want to make sure we have 1, 2, 3, 4, 5, 6, 7 bars. Again, try to evenly space it out as much as you can. And frequency goes from 2 to 25, so we want to make sure we make our scale large enough so that it fits on this y-axis. So here is 0. And again, I have 1, 2, 3, 4, 5, 6, 7 bars, so I'm going to space this out. 1, 2, 3, 4, 5, 6, 7, and I know I didn't do a great job of trying to be even there, but you want to be as even as possible. And again, use graph paper, that way we can make sure we're 100% even. And each of these is going to be the interval. So 0, 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to 11, and 12 to 13. So those are my numbers of hours. And frequency, again, I want to make sure I fit 2 to 25 on there, so I might go by 2s. Oh, that doesn't quite fit, so maybe I'll choose to go by 5s instead. So again, there you go. Pick something that'll fit. Alright, and then just basically make your bar chart. And I don't care if you make it colorful, it's up to you. I just want to see the bars drawn in. Okay, so 0 to 1 was 5, so we have 1 bar here. Again, try to make it as even as possible. 2 to 3 went up to 25. Okay, 4 to 5 went to 20. 6 to 7, 18, so we're going to estimate that to be right below 20. 8 to 9 is 12, so right a little bit above 10. 10 to 11 was 6, so just a little bit above 5. And then 12 to 13 was 2, so right a little bit above 0. So again, elements of our histogram, we want to make sure we've labeled. Each axis need a title for the graph, and then writing in your intervals and your frequency. So the big thing about this today, because you guys practiced this on your assignment the other day, is the second part, describe the shape of the distribution. So if you imagine this as a curve, right, you're thinking, okay, this is what it looks like as a curve. what is this? Is it skewed left, skewed right, or is it symmetric? Well, you can see how the tail is on the right, so we're going to say this is skewed right. Okay? And that's it for now. We'll talk about how this can affect, measures of center and whatnot in the next example. For now, I'd like you guys to try the you try problem. So draw me that histogram and then tell me this shape of this distribution. All right, go ahead and check. So hopefully yours looks something like mine, and you should have a distribution that is skewed left because you see how it has this big tail on the left. So most of the numbers are found on the right. And again, when you do this in your assignments, we'll use graph paper so your graphs won't look so much as sketches, so we can have a more accurate representation of numbers. Okay, let's take a look at the next concept. So how do we choose an appropriate measure? So here's where having that distribution is interesting, because we can choose a measure of center that can really represent the center of the data based on the distribution. So if we have something that is symmetric, right, meaning we have the mean kind of right here down the middle, right, it's right about average, we use the mean to describe the center, and then we're going to use standard deviation to describe the variation. Versus if you've got anything that's skewed left or skewed right, you can see how the average isn't actually really where the center of the data is. So we're going to choose to use the median instead to describe the center, and instead of using standard deviation, we'll use our 5-number summary, which is all about the medians to describe the variation. Okay? So for the next example, we're just kind of put it all together. We're going to draw the distribution and then talk about how we are going to choose what measure to talk about the center and what measure to talk about variation. So in example B, what's interesting here for us is, notice I don't have a frequency table for you. So what you need to do is you need to think about, well, how am I going to make our frequency table? And A is telling us we want 6 intervals beginning with 1 to 25. So let's make a frequency table using these intervals. All right, so we're looking at check amounts, the frequency, and then for just ease of graphing, let's look at our total. We want to have a total of 6 intervals. So 1, 2, 3, 4, 5, 6. The first interval being at 1 to 25. So we want to look at intervals of 25. So 1 to 25, then 26 to 50, 51 to 75, 76 to 100, 101 to 125, and 126 to 150. So all I did was looked at intervals of 25, right, going in order. And then what you want to do is tally up what we have here. So I might start with 65. Where does 65 go? It goes here in the 51 to 75. 40, where does that one go? 26 to 50. 10, 1 to 25. 100, 76 to 100. 75, 51 to 75. And I think you guys get the point. So go ahead and finish tallying that up and let's see what we get. All right, let's check your totals. So we should have 5, 1 to 25, 10, 26 to 50, 9, 51 to 75, 2 from 76 to 100, 1 from 101 to 125, and 1 from 126 to 150. You can also double check by adding up your totals to make sure we caught all those numbers. So 5 plus 10 is 15, plus 9 is 24, 25 from 6, 27, 28. And is that correct? 1, 2, 3, 4, 5, 6, 7 times 4 is 28. So I think I caught all of them. Then let's go ahead and graph this as our histogram. All right, there's that histogram. And then you want to think, well, how is this distribution looking, right? Is it skewed? Is it symmetric? Well, if I look at this, there's a huge tail on the right. So this would be considered skewed to the right, right? Which means the measure of center and variation, because it's skewed, needs to be the median and the 5-number summary. Right, so the median and the 5-number summary best represent the center and variation. Finally, I want you to think about this last question. The grocery store charges a fee for cashing checks that are greater than $75. How do you interpret these results? Well, if you think about it, starting right at 76, there's a huge drop in the data. So you might interpret this and say, well, it's skewed because most customers don't want to pay a fee. So if you go up to, 75, you're good, but as soon as you're over 75, you've got to pay a fee, so most customers don't want to pay that fee to use a check. Okay? So last thing, oops, there we go. So go ahead and try this you-try problem. I'll save you some time with the video and we'll check it together in class, but make sure you come to class with questions and think about how you're describing the distributions and what measures you choose based on if it's skewed or symmetric. Thanks for listening.